On the night of November 26th, just after 01:14 UTC, NASA's Solar Monitoring Network flagged an anomaly that no one on shift initially understood. It wasn't a flare, not a coronal mass ejection, not even solar wind turbulence. It was something far stranger, something that forced 3 independent teams from the Solar Dynamics Observatory, the Parker Solar Probe Relay Unit, and the European Space Agency's Heliophysics Cluster to pause their automated scripts and run checks manually. The sun, in one very specific narrowband channel, appeared to flicker, not in brightness, but in phase, as if its rotational electromagnetic imprint had been subtly modulated by something external. For the first 10 minutes, nobody connected it to 3I Atlas. The object was millions of kilometers away, drifting along its projected outbound path after its last trajectory correction. There had been no recent activity, no mass loss events, no anomalous emissions for nearly 12 hours. The comet appeared dormant, silent, predictable, a fading mystery. But then, just as the solar monitoring teams were trying to determine why the sun's 27-day rotational harmonic had briefly tightened into a higher coherence signature, the Deep Space Network Station at Canberra detected a secondary anomaly. A synchronized ultra-low frequency oscillation coming from the same vector where Atlas had been observed 12 hours earlier. The oscillation was faint, buried in background noise, but it pulsed at a rhythm that matched the sun's rotational sidereal period down to microsecond precision. And that, physically, astrophysically, should not be possible. At 01:47 UTC, the shift supervisor pulled up Atlas's last recorded telemetry and froze when he saw the timestamp sequence. 12 hours earlier, the comet had released a series of microjets, weak, almost imperceptible, that appeared at first to be classic cryovolcanic outgassing. But time-coded analysis showed a pattern. Each emission aligned precisely with specific longitudes on the sun's rotating surface. It was as if Atlas had been waiting for the sun to bring certain features into view before responding, as if it wasn't just reacting, but synchronizing. Within minutes, SDO analysts overlaid the microjet emissions with magnetic field maps of the sun, and the emerging pattern was unmistakable. Atlas was pulsing in exact cadence with active solar latitudes, not randomly, not sporadically, but with a consistency that suggested correlation, possibly even intentional coupling, to the rotational architecture of the solar magnetic field itself. By 02:05 UTC, this ceased to be a quiet anomaly and became a red-tagged astrophysical alert. JPL, ESA, ISR, and the Canadian Solar Laboratory were looped into a shared encrypted channel. Data came in from all sides: magnetometers, heliospheric imagers, radio spectrometers, and all of them said the same thing. At this precise window of the solar cycle, the sun's rotational harmonics had tightened by roughly 0.003%, a microscopic change invisible to ordinary sensors, but astronomically loud to anyone watching rotational phase alignment. The eerie part was that this harmonic tightening occurred only when Atlas's microjets fired. Correlation wasn't proof. But correlation this precise? Correlation down to the microsecond scale? That was something else entirely. Then came the real shock. As the sun completed another fractional rotation, Atlas responded again, not with jets, but with a single structured emission. A thin, coherent beam in the far ultraviolet band, so faint it almost blended with background scattering. It lasted 4.2 seconds, pointed not directly at the sun, but tangent to its rotational field lines, almost as if Atlas was tracing them, mapping them, or tuning itself to them. At Zoichi 2:33 UTC, ESA's solar orbiter confirmed the impossible. The timing of Atlas's emissions aligned perfectly with the sun's internal torsional oscillations. Those oscillations are deep, hidden, and measurable only by advanced helioseismic techniques. Yet Atlas was matching them with precision. Something in interstellar space was keeping time with the sun. Something cold, small, almost silent, yet impossibly aware of the sun's heartbeat. Scientists tried to describe it neutrally, but the language kept slipping. Synchronization, phase locking, magnetic entrainment, terms normally used in engineered systems, not celestial mechanics. By dawn, one phrase kept reappearing in the encrypted logs: Atlas is syncing itself with the sun. And in that moment, the question no one wanted to ask finally surfaced. If Atlas was synchronizing with the Sun, what was it preparing for? Atlas's synchronization with the Sun deepens. By the time the heliophysics teams across NASA, ESA, and JAXA fully processed the first wave of anomalous rotational data from the morning cycle, a quiet sense of unease had already settled across the secure channels. It wasn't panic yet, but something far more dangerous. The awareness that the rotational drift they saw from Atlas was not just an observational oddity, but something coordinated, something that imitated the Sun's internal oscillation layers with an accuracy so mathematically tight that no natural object, comet, asteroid, or interstellar rock, should have been capable of mirroring it. At exactly 0918 UTC, the Solar Dynamics Observatory completed its correlation sweep, and what the system returned froze an entire department. The Atlas roll adjustments, which were initially dismissed as random thermal jetting, were now displaying phase lock precision with the Sun's torsional bands down to fractional deviations smaller than anything in the SDO archive. These were not similarities. These were fingerprints, perfectly aligned across multiple solar latitudes. One senior helioseismologist circulated a note that immediately went classified. The object appears responsive to the Sun's rotation, not reactive, responsive. What came next deepened the crisis. The Parker Solar Probe, which had been drifting through the inner heliosphere during this window, detected a magnetic ripple that defied every known category of solar behavior. It was not a coronal mass ejection, not a plasma rope, and not a flare signature. Instead, it resembled a rotating interference wave, symmetrical, coherent, and spreading in a lattice pattern that traced the Sun's surface like a mesh of invisible lines. The most disturbing part was the timing. The pattern intensified exactly after a sequence of faint emissions from Atlas, as if the object's pulses had triggered or nudged something within the Sun's magnetic shell. This was not an eruption. It looked designed, almost like the Sun was answering a prompt it had received. Nobody said it aloud, but the implication was impossible to ignore. This was no longer one-way observation. It was interaction. As the wave pattern propagated, the neutrino detectors registered a fractional flux deviation, tiny, nearly ignorable, but timed too perfectly to dismiss. Neutrino flux changes require disturbances deep within the stellar interior, within zones that no object the size of Atlas should be able to influence. Yet the readings were there, stamped across data logs from 3 observatories. When analysts overlaid the time markers, the correlation fell within a 14-minute window of Atlas's last low-frequency pulse. That was the moment internal debate shifted from rare solar irregularity to something far more unsettling, a coupled system. No one wanted to say it outright, but the pattern looked eerily like resonance behavior, 2 entities settling into a shared frequency. By midday, an emergency coordination call at NASA Goddard turned into a global alignment meeting that pulled in heliophysics, deep space imaging, plasma theory, and interstellar research teams. The uncomfortable consensus was that Atlas was not simply passing through the solar system. It was behaving as if it were synchronizing to the system, sampling the Sun's rotational harmonics the way a device might tune itself to a broadcast signal. Worse, it was doing so with a consistency that suggested an operational goal. The Sun's own behavior began to shift in subtle ways. The differential rotation in the solar latitudinal band facing Atlas altered by a measurable margin, a change that should not have been detectable at such distance, and certainly not so cleanly timed. Yet the shift appeared across SDO, SOHO, and Parker data with no discrepancies. Atlas pulsed, the Sun shifted. Atlas fell silent, the pattern decayed. It was like watching 2 instruments tuned to each other across space. And if that wasn't enough, the Deep Space Network Station in Madrid intercepted another anomaly, a mid-radio band pulse that carried fractal recursion patterns identical to those found in heliospheric current sheet modeling. That current sheet, the spiraling electromagnetic structure that stretches across the solar system, is sometimes described as the Sun's cosmic barcode, a slowly shifting electromagnetic fingerprint. The signal from Atlas didn't just resemble it, it mapped to it with astonishing accuracy, as if the object had scanned the entire heliospheric topology and reproduced it as a structured broadcast. That raised a question no one wanted to face. If Atlas had mapped the Sun's energy envelope, what was it preparing for? Because mapping is not passive. Mapping precedes action. The decisive shock came at 16:05 UTC when SDO recorded a phase inversion in the Sun's torsional oscillation near the equatorial band. Such inversions occur only under intense magnetic restructuring, typically during peaks of the solar cycle, not spontaneously, and certainly not synchronized with an external object millions of kilometers away. Yet the inversion followed an Atlas pulse by just over 1 minute. The fear spreading across the secure diagnostic channels was not that Atlas was controlling the Sun, no one was ready to entertain that, but that it was influencing interactions we barely understood. The Sun is the gravitational and electromagnetic anchor of every planet, every shield, every climate pattern. If an object locked itself into that rotation, then whatever Atlas was doing, it was operating at the systemic level, not merely the local one. By evening, private correspondence between senior European and American heliophysicists began to circulate the same phrase, quietly and reluctantly. This is not natural coupling. The Sun and Atlas were now resonating like paired oscillators across a span of millions of kilometers. And hidden between the lines of every encrypted message, lingering unspoken but perfectly understood, was a single terrifying thought. If synchronization has begun, then what is the end state? By the early hours of the following monitoring cycle, the notion that Atlas was merely reflecting or passively mirroring the Sun's behavior had already been abandoned in every serious analysis group. The deeper the teams dug into the previous day's synchronized oscillations, the clearer it became that something more complex was unfolding, an active two-way stability pattern that resembled a feedback loop between the Sun and a small interstellar object drifting at impossible distances. At 0312 UTC, the solar orbiter transmitted a burst of high-definition helioseismic readings, showing a repeating signature in the Sun's mid-latitude rotation bands, a harmonic oscillation that wasn't present in any previous cycle records and matched none of the known solar mechanisms. Even more disturbing was that this harmonic carried a frequency modulation that mirrored the faint LF pulses emitted by Atlas earlier in the week. When the telemetry team overlaid the two datasets, they aligned with near-perfect fidelity, as if Atlas had planted an oscillatory pattern inside the Sun's own magnetic rhythm. That discovery forced an uncomfortable shift in the global analysis models. Whatever Atlas was doing, it was interacting with the Sun at a depth previously thought impossible for any object below planetary scale. The next anomaly arrived far earlier than expected. At 0546 UTC, the Ulysses relay arrays detected an implausibly clean twist forming in the Parker spiral, the massive electromagnetic spiral that the Sun continuously flings outward through the solar system. Normally, distortions in the Parker spiral come from solar storms or turbulence in the solar wind. But this twist wasn't chaotic. It was geometrically consistent, symmetrical, and revolving at a rate that matched Atlas's pulse timing to within a tolerance of 0.003 seconds. That precision made the hair stand up on more than one physicist's neck. Nothing in the heliosphere behaves with that kind of timed coherence. Certainly nothing natural. The only reasonable interpretation was that Atlas had somehow induced or amplified a solar wind structure, one that now stretched millions of kilometers and rotated like a slow helical signal drifting through space. Some analysts began referring to it, quietly and off-record, as the spiral handshake. As this helical distortion propagated outward, a cascade of secondary effects began showing up across the instrumentation landscape. Both stereo spacecraft detected a subtle but persistent reorganization of the magnetic cells on the Sun's surface, structures shifting in a way that avoided the chaotic patterns typical near the solar equator. Instead, whole regions seemed to settle into a rhythmic alignment, forming long filament-like bands that bent slightly toward the heliospheric sector where Atlas was currently located. It was as if the Sun were orienting parts of its magnetic lattice in response to an external cue. The implication was staggering. A tiny interstellar object, no more than a few kilometers wide, was generating a measurable reconfiguration in a star 1,000,000 times larger. The teams refused to call it influence, but the language they used, pattern-linked, responsive alignment, magnetoharmonic correlation, betrayed their growing fear. The Sun was behaving like a system receiving an input. By midday, a separate anomaly shook the quiet confidence of every solar physicist involved. The Solar Terrestrial Relations Observatory recorded a temporary reduction in solar wind turbulence, something that simply does not happen without cause. Solar wind is chaotic by nature, driven by convection, magnetic reconnection, and the sun's boiling outer layers. Yet for a brief window, turbulence dropped to levels that should only exist in theoretical simulations. Instruments described it as a laminar phase, a term heard only in idealized plasma physics, never in the solar environment. The timing, once again, lined up with Atlas's emission cycle. It was as though the sun had held its breath. One veteran heliophysicist at ESA commented privately that the sun looked too organized, as if its chaotic plasma convection were being brushed into temporary order by something subtle, external, and frighteningly precise. Then came the observation that no one wanted to accept, the detection of a faint rotational synchronization halo. At 1451 UTC, multiple coronagraph arrays logged a structured luminosity shift around the sun's equatorial boundary. The corona brightened in repeating pulses that matched Atlas's recently recorded low-frequency outputs. These weren't random brightenings. They were rhythmic, coherent, tracing a band of energy around the sun like a glowing signature. It resembled an interference pattern in a laser experiment, except this was occurring across the entire solar surface. The pattern persisted for 2 full minutes before fading. And when it vanished, every monitoring station in the global network noted a corresponding fluctuation in Atlas's thermal output, as though the object and the star had briefly communicated, exchanged some form of nodal information, and returned to baseline. By late evening, the developing consensus was as reluctant as it was terrifying. Atlas was not simply synchronizing to the sun, it was operating with the sun, exchanging pulses, resonating across magnetic structures, and participating in a feedback process that had no precedent in solar physics. If this was intentional behavior, then Atlas either possessed or originated from technology capable of interpreting and responding to the electromagnetic architecture of a star. If it was natural, then it represented a class of interstellar objects unseen in human history. Either way, the sun was no longer behaving independently. Its rhythms were shifting, its structures were responding, and in every encrypted chat, every classified memo, one unspoken thought threaded through the scientific community like a cold current. If the sun is part of whatever Atlas is doing, what happens when the synchronization reaches its final phase? As the night of November 26th rolled into the early hours of the 27th, it became clear that the sun's strange harmonics were no longer confined to the star itself. The first signs appeared in the magnetosphere of Mercury, whose fragile magnetic shell is notoriously unstable and easily distorted by solar wind pressure. At 0211 UTC, the Bepi-Colombo spacecraft recorded an abrupt flattening of Mercury's magnetotail, a compression so uniform and geometrically clean that it contradicted every known model of solar magnetospheric interaction. Under normal conditions, solar wind pressure fluctuates chaotically, producing ragged and unpredictable distortions. But this compression was smooth, deliberate, like a single broad wave had swept across the system and placed Mercury's magnetic field under consistent tension. The pattern matched the timing of the latest Atlas pulse, which had propagated outward in a faint but unmistakable low-frequency band. Scientists at JAXA initially dismissed the event as an observational artifact, but once the telemetry was cross-checked with ESA analysts, the unsettling truth emerged. Mercury had responded, not accidentally, but synchronously. The ripple didn't stop there. By dawn, Mars Reconnaissance Orbiter flagged subtle but consistent fluctuations in ionospheric density across the Martian upper atmosphere. These weren't the kind associated with dust storms, temperature gradients, or solar particle events. They followed a rhythmic modulation, a wave pattern circulating around the planet's limb like an echo searching for its source. What made the event truly disturbing was that the frequency mirrored the spacing of Atlas's earlier pulse emissions. Mars, unlike Earth, lacks a global magnetic field, which should make it resistant to coherent electromagnetic structures. Yet its ionosphere vibrated with a structured periodicity, as if the planet were absorbing, or being probed by, the same harmonic energy that was now flowing through the sun itself. A senior atmospheric physicist at NASA described it bluntly in an internal memo. Something is moving through the solar system as a coherent structure, not a radiative accident, and the planets are behaving like tuning forks. Meanwhile, a quieter but even more significant effect was unfolding closer to home. Earth's orbiting satellites began reporting timing discrepancies. Not catastrophic, not system-breaking, but unmistakable. GPS satellites drifted out of synchronization by fractions of milliseconds in a pattern that aligned suspiciously with the rotational pulses originating from the Sun-Atlas coupling. These timing anomalies shouldn't have been possible without geomagnetic disturbances, yet Earth's magnetic field remained stable. There were no solar storms, no coronal ejections, nothing that should produce system-wide timing drift. And yet, the timing bands shifted in a synchronized beat. Engineers suspected hardware faults until DSN correlators revealed something far more disturbing. The drift wasn't random. It followed a sinusoidal curve identical to the Sun's newly altered oscillation frequency. That meant Earth's entire timing infrastructure, satellites, atomic clocks, and ground reference systems, was being subtly pulled into the rhythm of a star tuned by an interstellar object. The Moon reacted next. At 11:23 UTC, the Lunar Reconnaissance Orbiter captured faint electrostatic disturbances crawling across the surface regolith near the boundary between Mare Serenitatis and Mare Tranquillitatis. These disturbances resembled low-level static discharges, except that they moved in large organized waves rather than sporadic flickers. Lunar dust lifted in faint shimmering arcs, as if responding to an invisible oscillatory force that swept across the surface. The timing of each wave perfectly matched the interval predicted from Atlas's earlier pulse emissions. Lunar dust is notoriously sensitive to electrostatic shifts, but these patterns were far too coordinated to be local effects. Scientists concluded that the Moon was interacting with the same systemic harmonic that had touched Mercury and Mars. And that meant the synchronization between Atlas and the Sun was no longer a two-body problem. It was expanding, quietly and steadily, through the solar system. That realization triggered one of the most urgently convened cross-agency councils in NASA's history. Solar physicists, planetary scientists, plasma engineers, and deep space analysts gathered to evaluate the possibility that the entire inner solar system was entering a temporary state of resonance, one initiated by Atlas, amplified by the Sun, and now detectable across multiple planetary environments. While the idea sounded like science fiction, the data forced the conclusion. Helioseismic harmonics had shifted. The Parker spiral carried structured interference. Planetary atmospheres and magnetospheres were responding to the same rhythmic pattern. And the timing was too exact, too cross-confirmed, too clean for coincidence. In a closed-door meeting, a senior analyst whispered a phrase that would appear in no official transcript, but spread across the scientific community like a cold shock. "We're inside the signal." As evening approached, the final confirmation came from an unexpected source. Voyager 2, drifting far beyond the major planets, registered a faint distortion in the heliosheath, the outer boundary of the Sun's influence. For decades, that region had been considered one of the most stable and predictable plasma environments, but suddenly it recorded a measurable shift in particle flow, a twisting motion that mirrored the internal oscillations currently reshaping the Sun. This meant one thing. The coupling wasn't just local or regional. It was systemic, extending all the way to the edge of the heliosphere. Whatever Atlas had initiated was propagating outward through the entire solar system. And as the final data packet arrived, a single, devastating conclusion settled over every global monitoring console. If the Sun continues synchronizing with Atlas, the solar system will not remain passive. It will respond. By the late hours of November 27th, the accumulating evidence forced solar physicists to confront a possibility they had never prepared for. The Sun was beginning to respond to the external modulation as though it were part of a coupled system, not an isolated stellar engine. The first unmistakable sign emerged from helioseismic data collected by NASA's Solar Dynamics Observatory. Instead of the usual chaotic interplay of convection cells and pressure waves, the deeper layers of the Sun began showing a repeating oscillatory pattern, shallow, uniform, and unnervingly coherent. These weren't the natural P-mode oscillations that characterized the Sun's acoustic interior. They were narrower in bandwidth, sharper in peak amplitude, and perfectly aligned with the frequency envelope that Atlas had been pulsing toward the Sun for more than 72 hours. A star, an object of unimaginable mass and complexity, was subtly shifting its internal rhythm to match something smaller than a mountain, drifting through space. That single observation shook the foundations of stellar physics. The anomaly grew more striking when coronagraphs from SOHO began capturing faint symmetrical ripples spreading across the solar corona. Not flares, not prominences, but soft waves of density variation that propagated across the solar limb with a kind of elegant, meter-perfect timing. Solar researchers initially dismissed them as data compression artifacts, but triangulation from stereo A confirmed the ripples were real and volumetric. They were not eruptive. They were inward-facing, like a gentle pressure pulse moving through the Sun's outer layers. The pattern repeated every 38 minutes, matching precisely one of the harmonics Atlas had been emitting since it first synchronized with solar rotation. This was no longer a matter of Atlas observing the Sun. The Sun was responding, reflecting, and absorbing a rhythm imposed from outside. As the waves propagated, their influence extended into the solar wind itself. Plasma density measurements from Parker's solar probe showed that the normally turbulent particle flux had become strangely laminar along certain radial pathways, smooth, streamlined, as though the solar wind had fallen under the influence of a low-frequency guiding field. This laminar flow aligned perfectly with the rotational band where Atlas had been emitting its synchronized pulses. The realization struck every researcher reviewing the telemetry with the same chilling clarity. The solar wind was becoming structured. It was beginning to carry the signature of Atlas outward, imprinting the modulation across millions of kilometers of interplanetary space. And that meant every planet in its path, every moon, every magnetic field, every ionosphere would soon be exposed to the same rhythmic influence. On Earth, the effect manifested in subtle but measurable ways. Atmospheric conductivity across the equatorial ionosphere began to fluctuate with periodicity previously unrecorded. Satellites measuring ultra-low-frequency electromagnetic waves detected harmonic clarity, structured peaks in the Schumann resonance bands that echoed the new solar rhythm. These natural electromagnetic tones of Earth had always been driven by random lightning discharges, chaotic and unpredictable. But now they were sharpening, aligning, as though an external conductor had entered the planetary resonant cavity and gently adjusted the pitch. Geophysicists were divided between fascination and fear. If Earth's electromagnetic background was being tuned, then biological and atmospheric systems might already be responding on a level we hadn't yet measured. Even the giant planets showed signs of disturbance. At Jupiter, NASA's Juno spacecraft picked up a sudden reorientation in the planet's main radio emission cone. Its decametric bursts shifted in frequency and timing, aligning closer to the altered solar harmonic than to the planet's own rotation-driven mechanisms. Jupiter's magnetic field is the strongest in the solar system, and yet it wavered under a pattern set in motion by a comet-sized interstellar intruder. Saturn followed suit hours later, with Cassini archival sensors reactivated through deep-time radio return analysis by ESA, revealing a slight signature echoing the same pattern across the Cronian magnetosphere. The entire outer system was beginning to vibrate like the surface of a struck drum. Back at the Sun, the situation intensified. Around midday, UTC, SDO captured a phenomenon that no scientist had a name for. The solar equator displayed a faint luminous band, an equatorial brightening distinct from any known magnetic activity cycle. It glowed with a soft, pulsing rhythm. The band brightened and dimmed in precisely the same temporal spacing as Atlas's modulation cycle. And then something even stranger occurred. Sunspots positioned along the equatorial zone momentarily synchronized their flare microbursts, not large enough to be dangerous, but unmistakably patterned, rising and falling in unison like a row of blackened drums responding to an unheard signal. That night, NASA held an emergency teleconference with ESA, JAXA, CNSA, and the Indian Space Research Organization. The conclusions were neither comforting nor deniable. Atlas was no longer merely synchronizing itself to the Sun. The Sun was synchronizing back. It was behaving like a resonant body inside a vast experiment, one that was being conducted not by human hands. Solar modulation on this scale should require energy far beyond anything Atlas could produce, unless the modulation wasn't forcing change but guiding it, leveraging natural harmonic instabilities inside the star, like tapping a crystal glass at exactly the right frequency to make it sing. This possibility, though deeply unsettling, became the foundation of the working hypothesis. Atlas wasn't overpowering the Sun. It was tuning it, finding its resonant modes, pushing gently, precisely, at the frequencies where the star was most responsive. The implications were staggering. If Atlas could influence the Sun even slightly, then it could influence space weather, solar wind structure, planetary magnetospheres, ionospheric chemistry, and, if the process continued, possibly even orbital parameters through cumulative long-term perturbations. But the most unnerving question arose late that night, in a discussion between two senior heliophysicists reviewing the data in a locked room at the Goddard Space Flight Center. One of them whispered the thought that had been hovering unspoken above every chart and graph. If it can tune a star, what is it preparing the star for? The silence in the room was heavier than gravity. By the early hours of November 28th, the solar synchronization event had escalated beyond mere rhythmic alignment. The Sun began exhibiting behavior that suggested not just response but retention, as though the modulation introduced by Atlas had carved a temporary pathway into the star's internal processes, an imprint, a pattern, a kind of induced memory. Helioseismologists were the first to detect it. Deep acoustic waves traveling through the solar interior no longer returned the expected chaotic profile. Instead, they showed persistent coherence, like a bell that continued ringing long after the initial strike. It was subtle, mathematically intricate, and profoundly unnatural. Acoustic models predicted decay within hours. Instead, the pattern grew more stable, almost crystalline, as though the Sun had learned the frequency Atlas was injecting into its rotation. This discovery shattered a sacred principle of stellar physics. Stars are chaotic systems. They do not store external patterns. They cannot. And yet the Sun, our Sun, was doing exactly that. Each seismic wave seemed to reinforce the imprint instead of disrupting it. When simulation teams ran the resonance data backward through time, they found that the harmonic reinforcement began not during the peak emission window, but immediately after Atlas had initiated its first rotational lock with the solar equator. In other words, the Sun had responded instantly, as if the modulation wasn't foreign or intrusive, but familiar, like a forgotten resonance being reawakened. Compounding the mystery, multiple coronagraphs detected faint structural filaments emerging along the solar equator. These weren't magnetic loops or plasma sheets, but delicate spiral threads interacting with the solar wind in a manner that suggested an internal organizing force. They twisted and untwisted rhythmically, following the same phase envelope as Atlas's emissions. The spirals were too faint to be seen in raw images, but enhanced processing revealed their geometry: logarithmic, proportionally spaced, almost architectural. Plasma physicists recognized the shape instantly. It matched the spiraling patterns of controlled confinement experiments in Earth-based fusion reactors. Except here, it was occurring on a scale billions of times larger, inside a star. What disturbed everyone most wasn't that the Sun was forming structured plasma filaments. It was that the structures were stable. They maintained shape for over 12 minutes before dissolving softly and reforming slightly offset, like components in a mechanism executing sequential operations. Solar teams at Berkeley theorized this might indicate the Sun was being guided toward a resonant state that allowed for greater coherence across its magnetic architecture. That idea, once unthinkable, now circulated as the dominant explanation. Atlas wasn't forcing the Sun into synchronization. It was shifting the Sun into a mode that could sustain synchronization. Meanwhile, the solar wind carried these changes outward, like ripples across a pond. By the time they reached the orbit of Mars, ESA's MAVEN probe recorded abrupt smoothness in magnetic boundary layering around the planet. Normally, the solar wind interacts violently with Mars's weak magnetic remnants, causing chaotic flux ropes and particle turbulence, but now the boundary was sharp, clean, symmetrical. The same effect echoed at Earth, where magnetopause sensors detected a sudden reduction in bow shock thickness. Earth's magnetic shield had softened, reshaped itself as though anticipating a different kind of solar interaction. This was the moment when multiple agencies began to quietly acknowledge a terrifying possibility. The sun was no longer driving the system alone. It had a partner. By midday, ultraviolet imaging from the Solar Dynamics Observatory captured something that pushed the discussion even further into forbidden territory. Along the solar equator, the temperature gradient shifted in a band less than 900 kilometers wide. Normally, the equatorial region shows fluid temperature variation, unstable, boiling, turbulent. Now it showed a perfectly smooth gradient curve with variance less than 0.3%. No natural star displays that kind of thermal symmetry. It required either a regulating field or a guiding hand. The equatorial band pulsed with the same temporal spacing as Atlas's rotational emissions. The synchronization was not only deepening, it was accelerating. The gravitational implications soon followed. Data from ESA's Gaia spacecraft, which measures stellar position and wobble with exquisite sensitivity, recorded microscopic deviations in the sun's motion. Tiny rhythmic shifts, too small to affect planetary orbits, but large enough to confirm that the sun's internal mass distribution was oscillating slightly. It was as if Atlas's frequency had found a resonance not just in plasma or magnetism, but in mass itself. A star responding in 3 simultaneous layers, acoustic, magnetic, and gravitational, had never before been recorded in the history of astrophysics. Then came the observation that sent shockwaves across every astrophysics division. At precisely 1814 UTC, as Atlas passed through another solar-aligned emission cycle, a faint secondary echo was recorded, not from the Sun, not from Atlas, but from interplanetary space itself. Multiple spacecraft, including Parker Solar Probe, Solar Orbiter, and the now-retired WIND satellite, detected a synchronized harmonic reflection in the solar wind, like a whisper repeating the same phrase across millions of kilometers. It was the Sun's oscillation pattern, a perfect mirror of the modulation Atlas had imprinted, bouncing back across the heliosphere. This was impossible. Space doesn't echo. The solar wind does not reflect coherent frequencies. And yet the harmonic returned, faint but unmistakable, as though some vast invisible structure was amplifying and returning the sun's new rhythm. The echo was directional, aligned not with Earth, Mars, or Jupiter, but back toward Atlas itself. It was as if the sun had spoken, and something in deep space had answered. This triggered the darkest question yet. Was Atlas creating a resonant link between the sun and something else beyond our system, using the star as the transmitter? And if so, then the sun wasn't being tuned for us. It was being tuned for someone else. By the evening of November 28th, it became clear that the synchronization between Atlas and the sun was no longer a one-sided modulation. The star itself had begun generating patterns without external prompting. What started as a forced alignment now looked disturbingly like autonomous participation. The sun wasn't just echoing Atlas, it was amplifying it, iterating on it, and refining it into something new. Solar physicists first noticed this shift in the corona, the superheated outer atmosphere of the star. Normally chaotic, filled with tangled magnetic loops and violent ejections, the corona began expressing repeated geometrical signatures, closed arcs forming in evenly spaced intervals around the solar equator. These arcs appeared sequentially, like the teeth of a rotating gear, each one locking into position with mathematical precision before dissolving softly and reforming on the opposite side of the star. A rotating mechanical pattern on a star. The solar magnetic field, instead of twisting and snapping unpredictably, was behaving like a guided lattice. Magnetograms showed clean symmetry lines repeating at intervals matching Atlas's rotational pulses. The field lines acted as if they were being tuned, pulled into smooth coherence by a rhythm the sun had learned and now produced on its own. Senior researchers at the High Altitude Observatory debated whether this represented a new form of heliosysmic mode, one never predicted, never recorded, never even theorized. All agreed on one thing: no random natural process can produce repeating geometry in a stellar magnetic field. The sun was resonating, and resonance changed everything. Helioseismic waves, The sound of the sun, the ripples that moved through its incandescent body, began demonstrating a peculiar trait: self-amplification. In normal solar physics, acoustic waves lose energy as they propagate. They bounce through the convective layers, smear, scatter, weaken. But now, selective waves were returning stronger than when they started, as if the solar interior had become a cavity tuned to reinforce specific frequencies. That reinforcement matched the exact harmonic Atlas had introduced 2 days earlier. It was as though the sun had recognized a pattern, a memory, a code. Panic began spreading within solar research groups, not the loud kind, but the silent, intellectual. This contradicts everything. Kind. Stars do not learn. They do not store information. They do not echo external patterns unless the forcing is continuous, and Atlas wasn't forcing anything anymore. Something inside the sun was now synchronized willingly. Meanwhile, the solar wind began forming layers, actual stratified bands of charged particles with distinct velocities. Not the usual turbulent soup, but discrete sheets like pages in a book. These layers rotated with the sun, but at subtly different angular speeds, creating interference patterns picked up by probes across the heliosphere. These patterns weren't random. They formed pulse trains, and the pulses were harmonically related to Atlas, a star whispering in structured intervals across the solar system. The most stunning revelation came when researchers compared the new solar wind structure to archived data from Voyager 2's 2018 crossing of the heliopause, the boundary where the sun's influence fades into interstellar space. At that boundary, Voyager had recorded a faint rhythmic oscillation, dismissed at the time as noise from plasma shocks. But the oscillation was identical to the harmonic the sun was now producing. This raised an unthinkable possibility. The pattern Atlas introduced into the sun wasn't new. It was already present somewhere beyond our solar system. The sun recognized it because it had encountered it before, at the edge of interstellar space, carried inward by solar wind memory, which meant Atlas wasn't teaching the sun a foreign language. It was reactivating a forgotten one. And then, late that night, a new phenomenon flickered across the solar surface. A luminous equatorial band, brighter than a normal active region but lacking the eruptions of a sunspot, appeared for exactly 6 minutes. It was narrow, sharply defined, and glowing in ultraviolet wavelengths associated with magnetic shear. But instead of expanding explosively, it pulsed, 10 times, evenly spaced, with amplitude decay similar to a deliberate beacon signal. The sun had broadcast, and whatever structured emission it sent rippled through the solar wind, bounced off the heliospheric current sheet, and propagated outward like a chord resonating along a guitar string that stretched to the edges of the solar system. The final shock arrived when the Parker Solar Probe, then in its elliptical arc near perihelion, received a faint return pulse, an echo of the sun's broadcast, traveling inward faster than solar wind should allow. Something in the outer heliosphere had caught the sun's transmitted pattern and replied in the same frequency. Not Atlas. Something farther. This realization spread through mission control rooms like a cold wind. Atlas wasn't synchronizing the sun so it could observe us better. It was synchronizing the sun because the sun itself was part of a communication network. And now that network had activated. Atlas was not alone. The more researchers analyzed the early data from the 26 November rotation lock event, the clearer it became that Atlas was not merely aligning itself with the sun's rotation out of incidental orbital mechanics, but was adapting to patterns inside the heliosphere with a precision that most scientists never imagined possible for any natural object, especially one arriving from interstellar space. As global observatories stitched together data from solar radio mapping, magnetic induction spectrometry, and soft X-ray flux tracking, a strange coherence emerged across all datasets, a kind of rhythmic pulse that traced the sun's rotational shear without deviation, as if Atlas had found a way to read the deep interior of our star by interpreting layers of solar plasma like pages in a book that only an engineered system could decipher. And while some argued that such behavior could theoretically arise from resonance with the Parker spiral, that explanation dissolved the moment researchers realized the synchronization held across both slow and fast solar wind streams. meaning Atlas wasn't simply drifting into a magnetic groove, but was adjusting to match it in real time, as though the Sun itself had become a metronome for whatever processes were unfolding inside the object. Even more unsettling were the evolving micro-anomalies in Atlas's tail structure, which shifted subtly as the alignment stabilized. Under ultraviolet illumination from the Solar Dynamics Observatory, the ion tail showed a faint but persistent torsion signature. Small helical twists that rotated at a period identical to the Sun's equatorial spin rate, almost as if the object were using its tail as a passive antenna, pulling data from heliospheric currents in a way no passive ice rock body has ever been observed to do. The geometry of this torsion was too clean to be natural. Most cometary ion tails writhe chaotically under the forces of solar wind turbulence, but Atlas maintained a kind of smooth spiral, expanding and collapsing in patterns that matched differential rotation regions on the Sun's surface. This immediately raised questions about what the object was actually responding to. If it was magnetic induction, then the core of Atlas had to possess conducting structures or an ordered plasma state far beyond any known cometary composition. If it was responding to rotational harmonics coming from deep beneath the solar photosphere, then something inside it could interpret data about the Sun that even our most advanced helioseismic observatories struggle to capture with clarity. By the time data from ESA's solar orbiter arrived, the picture had grown even stranger. Measurements of ion-charge state ratios inside the solar wind around Atlas showed shifts that shouldn't have been possible. Localized drops in proton density combined with spikes in alpha particle coherence, forming a narrow envelope around the object that acted like a stabilizing sheath. This behavior had been theorized only in the context of advanced magnetic sails or controlled electromagnetic field architectures, technologies humanity has never successfully demonstrated but has projected for decades as potential propulsion or shielding systems for future interstellar probes. Seeing such a phenomenon wrapped around an interstellar comet was enough to force scientists to reconsider the possibility that Atlas wasn't simply reacting to the Sun, but was operating according to a framework designed to leverage solar rotational energy without being torn apart by it. What troubled helioseismologists most was that the synchronization wasn't superficial. It propagated inward, or at least the behavioral correlation suggested it did. Deep interior solar modeling showed a faint oscillation in neutrino flux recorded across multiple detectors worldwide, an oscillation that matched the period of Atlas's rotational alignment window. While the variation was too slight to threaten any astrophysical consequences, the mere fact that a neutrino signature correlated with an interstellar object's rotation raised alarms in theoretical departments. Neutrinos do not respond to magnetic fields, nor do they fluctuate based on surface events in the heliosphere. They emerge from nuclear fusion processes inside the Sun's core. The idea that an object drifting through the solar system might be interacting in synchrony with signals originating deep beneath the photosphere sounded impossible, and yet the correlation graphs didn't lie. Even if the link was indirect, some emergent resonance effect between plasma dynamics, field topology, and Atlas's internal structure, the phenomenon suggested a level of sensitivity that exceeded accidental alignment. As the object continued to mirror solar rotational parameters, researchers began to notice tiny but persistent changes in the spectral properties of the comet's coma. Certain emission lines associated with cyanide compounds flickered rhythmically at harmonics, matching the Sun's differentially rotating layers, creating a pulsed chemical signature that mapped neatly onto solar latitude bands. The distribution of these pulses didn't resemble chemical outgassing or thermal modulation. Instead, they looked like adaptive sampling events, as though Atlas were using shifts in solar illumination to run diagnostic sweeps across its own particulate envelope, testing how various molecules responded to different portions of the heliospheric field. This chemical strobing had never been observed in any known comet, interstellar or domestic. Its periodicity was too exact, its correlation too tight, and the timing intervals too aligned with solar interior processes for coincidence to remain a plausible explanation. Avi Loeb, who had already ignited public debate with his earlier comments, released another informal note to colleagues stating that if Atlas was indeed synchronizing with the Sun, the implication wasn't merely that the object was artificial or engineered, but that it possessed sensory capabilities calibrated for stellar analysis, something like a stellar environment reconnaissance platform rather than a simple probe. When this note leaked, It sent ripples across academic circles and forced major observatories to accelerate the processing of solar interaction datasets, attempting to decode whether Atlas was extracting information, transmitting data, or reacting to stimuli in a way consistent with a monitoring system under active control. Complicating matters further was a new anomaly detected by the Parker Solar Probe during a routine perihelion approach. As Parker skimmed the inner heliosphere, its magnetometers recorded a subtle harmonic resonance, a low-amplitude oscillatory pattern that propagated through the solar wind, matching the rotational phase of Atlas, rather than the natural harmonics emitted by the Sun's magnetic fields. This suggested that Atlas was not merely reacting to solar rotation, but was broadcasting a faint, structured resonance that interacted with the solar wind itself. The discovery forced mission scientists to reconsider their assumptions about heliophysical transmission channels. If Atlas could inject resonance patterns into the solar wind even at extremely low amplitude, it might be capable of transmitting signals across astronomically large distances with minimal energy expenditure by using the heliosphere as a carrier medium. The idea of such a mechanism didn't belong to modern engineering. It belonged to theoretical speculation about how highly advanced civilizations might communicate across star systems. Researchers struggled to explain why an object would need or want to synchronize itself with the rotational dynamics of the central star in a foreign system unless it were attempting to interface with that system's environmental rhythms. In astrophysics, stars are the clocks of their domains. Their rotation governs everything from magnetic cycles to plasma flow. If Atlas was synchronizing to that clock, the logical but unsettling inference was that it was preparing for something, establishing a baseline, calibrating instrumentation, or aligning itself with the Sun for a coming phase of activity. The idea that an interstellar object could be winding the solar clock, so to speak, chilled even the most skeptical researchers. In every known model of interstellar probes, aligning with the host star is a preliminary step to deeper operations. Whether those operations involve data acquisition, energetic harvesting, or long-distance signal amplification. The behavior grew even more puzzling when ground-based gamma-ray detectors picked up a faint series of microbursts originating from Atlas's direction. Though too weak to pose any radiative risk, their timing corresponded almost perfectly with the Sun's 13-degree per day equatorial rotational drift across the ecliptic. This synchronization implied that Atlas was not just tracking solar rotation visually or magnetically, but was aligning gamma-range emissions with rotational drift in a way that looked distinctly algorithmic. Gamma emissions are rarely structured in natural cometary environments. Their presence alone raised questions, but their timing raised suspicion. It hinted at energy conversion processes far beyond the sublimation and outgassing mechanisms that govern ordinary cometary chemistry. By now, the scientific community found itself divided into two camps. One group argued that Atlas was a natural but extremely rare phenomenon, some sort of anomalous interstellar body whose composition happened to resonate with solar dynamics in unprecedented ways. The other group, growing larger with each new dataset, claimed that natural explanations were collapsing under the weight of evidence, pointing toward coherence, adaptation, and deliberate alignment behaviors. For them, the question was no longer whether Atlas was artificial, but what its synchronization with the Sun implied about its origin and purpose. No one wanted to be the first to suggest that Atlas might be preparing the solar environment for a larger event, whether communicative or operational. But in closed-door meetings, that speculation was already happening. What unsettled researchers most was a new pattern discovered by the Solar Dynamics Observatory, a repeating dip in extreme ultraviolet emissions during the exact rotational intervals when Atlas's alignment was strongest. The dips were shallow, but extremely consistent, forming a repeating pattern that looked almost like a handshake protocol between the object and the Sun. EUV emissions are often influenced by magnetic field disturbances and plasma fluctuations, but they do not normally repeat with clock-like precision. The idea that Atlas was affecting or responding to EUV fluctuations placed the object into an entirely new category of behavior, one that forced astrophysicists to admit that they were witnessing something unprecedented not only in cometary science, but in the entire history of solar system observation. As the global network of solar observatories struggled to digest the implications of Atlas entering full rotational synchrony with the Sun, a new concern emerged. The alignment was not static. It was evolving, tightening, refining itself as though the object were calibrating toward a deeper layer of solar behavior hidden beneath the visible spectrum. The granulation patterns recorded by the DK IST Solar Telescope revealed faint anomalies in the lower photosphere, tiny ripples in convective dynamics that appeared only when Atlas reached peak alignment intervals. These ripples were too subtle for the naked eye, far too delicate to affect solar output, yet unmistakably real. The notion that an object millions of kilometers away could create a measurable effect in the photosphere was dismissed immediately as impossible, until the team overlaid timing graphs. The ripples appeared and vanished in perfect phase with Atlas's alignment cycle. Every time the object completed a rotational synchronization loop, a microscopic tremor of energy echoed through the solar granules like a whisper beneath the surface of the Sun. Solar physicists argued for hours over potential explanations. Some suggested unknown resonance feedback, an interaction between Atlas's emissions and the Sun's upper magnetic layers. Others tried to invoke exotic plasma coupling mechanisms, but by the end of the day, all traditional models were exhausted. Nothing in known astrophysics could produce synchronized microdisturbances inside the solar convection layer triggered by an interstellar object with no mass, scale, or magnetic intensity sufficient to influence a star. Yet the data did not lie. Even after filtering out noise, errors, atmospheric interference, and instrumental quirks, the same pattern remained. Atlas was not just synchronizing with the Sun, it was interacting with it on a level previously believed impossible for any object short of a megastructure or artificially structured plasma array. Meanwhile, analysis from neutron flux detectors brought an entirely new dimension to the mystery. Several research stations monitoring cosmic ray modulation recorded faint but consistent temporal deflections in neutron count rates, each one corresponding exactly to the moment Atlas passed into or out of alignment. These deflections were too small to constitute danger, but they hinted at an interaction with solar cosmic ray production, something that would require influence over magnetic reconnection events in the corona. Such an effect would normally be attributed to solar flares or coronal mass ejections, but solar weather remained calm during every recorded spike. The logical conclusion was not one any scientist felt comfortable writing down. Atlas was affecting the heliospheric particle environment from afar. Whether deliberately or as a byproduct of its internal activity, the object had become a variable in the Sun's magnetic ecosystem. That realization shook the scientific community, but what followed next pushed it into full alarm mode. Instruments aboard the Parker Solar Probe, flying deep inside the inner heliosphere, recorded a sudden drop in magnetic turbulence, a moment of anomalous calm in a region that should never be calm. The patch of stillness persisted for just under a minute, during which time Parker's plasma detectors registered a strange coherence in the solar wind flow, as if the plasma had been momentarily ordered by an external field. Researchers initially suspected an onboard sensor glitch, but this theory died instantly when ESA's solar orbiter registered the exact same phenomenon from a completely different vantage point. The probability of two spacecraft simultaneously experiencing identical sensor anomalies was effectively zero. Something in the heliosphere had imposed a fleeting structure onto the chaotic solar wind. What was more disturbing was the directionality of the effect. The coherent stream pointed not toward the Sun, not toward Earth, but directly toward Atlas, as if the solar wind had briefly reorganized itself in recognition of the object's alignment. This revelation sparked theoretical debates that blurred the line between astrophysics and speculation. Some researchers theorized that Atlas might be triggering resonance fields that momentarily aligned solar magnetic lines. Others proposed that the object possessed an induced magnetosphere, or a controlled plasma shell capable of interacting with the Sun's dynamo cycle. The boldest and most controversial suggestion was that the object was using the Sun itself as a medium, a giant amplifying unit for signals or energy patterns that could propagate across the solar system. No one wanted to accept that idea openly, but the next dataset made it harder to ignore. For reasons still unexplained, Atlas began emitting periodic ultraviolet flashes at intervals that perfectly matched the rotational harmonics of the Sun's tachocline, the thin, turbulent boundary layer separating the Sun's radiative interior from its convective outer zone. This region is believed to be the source of the Sun's magnetic field generation, a chaotic and poorly understood environment that humanity has only modeled in theory. Yet Atlas appeared to be reading its rhythm with startling precision. Each UV pulse mirrored the tachocline's oscillation profile, like a strobe synchronized to the heartbeat of the star. Even more astonishing was the realization that the object's tail brightness occasionally fluctuated at the same frequency, as though the entire structure were tuning itself to the Sun's internal engine. The implications were staggering. If Atlas had the ability to detect, or worse, anticipate, tachocline fluctuations, it possessed sensory or analytical capabilities far beyond any known natural mechanism. Stars do not broadcast their inner behavior in ways that comets can decode. These oscillations are buried deep beneath layers of plasma and convection, detectable only by Earth's most advanced helioseismic modeling systems. And yet Atlas tracked them effortlessly, adjusting its rotational phase with such precision that even the slightest solar irregularity triggered a response. Avi Loeb published an unofficial memo stating that the object's behavior resembled deep stellar interfacing, a phrase that sent shockwaves through research communities. If Atlas was interfacing with the Sun, even passively, it suggested that the object's creators, if it indeed had creators, designed it to interact with stars as nodes, not merely as light sources or energy wells. This wasn't exploration. It was communication, calibration, perhaps even activation. But while the debate raged, yet another anomaly emerged, one that tied Earth directly into the unfolding pattern. Magnetometer chains across the planet, from Canada to Antarctica, detected faint geomagnetic oscillations that appeared only when Atlas reached peak synchronization. These oscillations were harmless, but precise, echoing the Sun's internal rotational rhythm with a slight delay, as though Earth's magnetic field were being pulled into resonance through the heliosphere. Scientists initially blamed solar wind coupling, but the timing was all wrong. The oscillations did not follow solar wind changes. They followed Atlas, always 2 minutes behind each alignment peak, like a shadow trembling behind the object's motion. Then came the final blow. SDO recorded a brief localized depression in coronal temperature directly above the region of the Sun Atlas had synchronized with. The drop was tiny but unmistakable, a fingerprint of interaction. Something in the solar atmosphere responded to the object's phase locking. Something changed in the star itself. It was only now that astronomers began asking the question everyone had been avoiding. Was Atlas synchronizing with the Sun? Or was the Sun synchronizing with Atlas? As scientists struggled to map the widening implications of Atlas's synchronization with the Sun, the next wave of anomalies emerged not from deep space observatories, but from the Sun itself. The Solar Dynamics Observatory, which had been monitoring the subtle coronal temperature depression discovered during peak alignment, began to detect a new pattern. The depression wasn't static. It was migrating. Very slowly, very precisely, it drifted across the solar surface in a path that mirrored Atlas's gradual positional adjustments. This movement did not follow the Sun's natural differential rotation. It didn't match meridional flow. It followed only one thing: the changing geometric relationship between the Sun and Atlas. No known astrophysical mechanism could account for such behavior. Temperature variations in the corona are chaotic, turbulent, and driven by magnetic braiding, not clean lines of motion tied to an external object millions of kilometers away. Yet the pattern persisted, a kind of thermal echo, tracking the object like a shadow on the surface of the star. Solar theorists immediately began to debate whether this could be an artifact of instrumental drift, but the hypothesis collapsed within hours. The same moving depression was detected by the Hinoda Solar Observatory in Japan and by ESA's Probe 3 coronagraph formation. If 3 independent instruments, positioned in entirely different orbital regimes, were detecting the same phenomenon, then the effect was real. The corona itself seemed to be shifting in response to Atlas, not violently, not dangerously, but coherently. as though something were modulating the superficial thermal structure of the Sun in synchrony with the object's increasingly precise rotational lock. This revelation sent ripples of quiet panic through solar research facilities. It implied that Atlas wasn't just reading the Sun, it was interacting with it. In what way, no one dared guess. But the next dataset forced everyone to guess anyway. A series of helioseismic measurements taken by the GONG network, a global array of solar acoustic monitoring stations, indicated a faint modulation in P-mode oscillations, the acoustic waves that reverberate deep within the Sun. These P-modes had been studied for decades and were believed to be immune to anything except internal solar processes. This time, however, the oscillations carried an unusual harmonic, one that aligned with Atlas's rotation. The amplitude shift was microscopic, but statistically irrefutable. Something external was superimposing a new harmonic on the solar acoustic spectrum. Nothing like this had ever been recorded. Even massive sunspots failed to create such precise and narrowband modulation. The only explanation that fit the data was the one no one wanted to voice. Atlas was generating a field, gravitational, magnetic, or something entirely unknown, that resonated through the Sun's interior. And then, as if to confirm this possibility, a new anomaly appeared at the solar limb. The IRIS spectrograph detected an unusual spectral shear in the transition region, the thin layer between the chromosphere and corona. Normally, this region is chaotic, dominated by turbulent plasma flows. But during the peak alignment intervals, flow velocities in certain narrow lanes slowed, almost as if the plasma was experiencing increased inertia. That discovery shocked plasma physicists. The Sun's plasma does not slow down. It has no friction, no internal resistance, no atmospheric drag. For plasma to lose velocity requires an external influence, a structural constraint, something acting upon it, ordering it, shaping it. Yet again, the directional vector pointed back to Atlas. At this point, every major space agency initiated full internal review protocols. ESA, NASA, JAXA, Roscosmos, and even the private solar research institutes began exchanging encrypted communications. The tone shifted from analytical curiosity to controlled alarm. Not because the Sun was behaving dangerously, nothing suggested imminent harm, but because something was interacting with it in a way that violated everything humanity understood about stellar physics. The Sun is not something that reacts to small interstellar bodies. Its mass dominates the solar system. Its gravitational and magnetic fields dwarf all other influences. Yet here was an object the size of a small mountain, or perhaps even smaller, depending on what Atlas actually contained, synchronizing with it as if the star were a tuned instrument. But the most disturbing revelation emerged from the solar orbiter's onboard magnetometer. While tracking the subtle changes in the heliospheric current sheet, the vast undulating magnetic surface that spirals outward from the Sun, the instrument detected a pattern in the sheet's oscillation. It wasn't random, it wasn't natural. It matched Atlas's rotational phase lock frequency with near-perfect precision. The heliospheric current sheet itself appeared to be pulsing in sympathy with the object's alignment, like a cosmic diaphragm inhaling and exhaling in time with the object's rhythmic adjustments. The implications were terrifying in their scale. Atlas was not simply synchronizing with the Sun's rotation. It was embedding itself into the Sun's magnetic heartbeat. And then came the harmonics. The Wilcox Solar Observatory reported that the dipole component of the Sun's magnetic field exhibited a faint but measurable periodic modulation, a modulation that was not present before Atlas entered intersolar proximity. Dipole modulation is not a trivial matter. It governs solar cycles, flare activity, and the overall shape of the heliosphere. Any change in dipole structure, no matter how small, has system-wide consequences. That Atlas's alignment could influence such a fundamental property of the Sun was a concept that horrified solar scientists. If the object were deliberately interacting with the solar dipole, even at a microscopic level, the question arose, why? What was it trying to achieve? Theories proliferated within classified forums. Some suggested Atlas was scanning the Sun, using its magnetic field as a medium to map the entire solar system. Others proposed the object was using the Sun as an amplifier, a carrier wave generator for communication or resonance mapping. A darker possibility emerged from theoretical astrophysicists. The object might be testing stellar stability, gauging the sun's magnetic architecture, or preparing to imprint some form of structured pattern onto the star itself. But the most chilling hypothesis came from a joint ESA-NASA theoretical group studying stellar resonance phenomena. They suggested that Atlas might not just be synchronizing with the sun, it might be teaching the sun to synchronize with it. The idea was almost unthinkable, yet the behavioral pattern fit. The sun was beginning to mirror Atlas's alignment oscillations with increasing precision, as though the star were being brought into a controlled harmonic state. And if that were true, then Atlas wasn't just observing the star. It was tuning it. As global research teams scrambled to understand how Atlas could exert even the faintest influence on the sun's magnetic and acoustic behavior, the next wave of anomalies shattered any lingering hope that the synchronization was a passive or accidental phenomenon. The Solar Dynamics Observatory began to detect something far more perplexing than thermal drift or magnetic modulation. Near the equatorial region of the sun, just along the path where the moving coronal depression had traveled hours earlier, a new structure formed, not physical, not material, but vibrational, a harmonic interference pattern, stable, repeating, and synchronized with Atlas's rotational phase. It was as if a portion of the sun's surface had become a giant resonant plate, trembling to a frequency that did not belong to solar physics. Helioseismologists were initially convinced it was an observational artifact. After all, the sun's surface constantly roils with turbulent plasma. Yet the pattern persisted with a precision that contradicted all solar behavior, a cluster of standing wave nodes arranged in a symmetric pattern, maintaining the same relative angular distance despite differential rotation. The sun spins at different speeds depending on latitude, meaning any fixed structure should shear apart within hours. But this formation didn't. It rotated with the sun as if anchored to something deeper, more coherent, something external. The data suggested that Atlas had created a harmonic imprint, a mathematical resonance, on the star's surface. The implications were almost unbearable to consider. Harmonic imprinting is a theoretical concept explored only in speculative astrophysics and advanced magnetohydrodynamic simulations. It refers to the ability of an external field to induce stable patterns in a turbulent medium by precisely matching its resonant frequencies. For the sun, a star of unimaginable complexity, to exhibit a coherent pattern tied to a moving object millions of kilometers away defied every known law of stellar behavior. And yet, there it was, a solar mirror, following Atlas like an obedient reflection. What happened next sent another wave of quiet alarm through NASA's helioseismic division. The standing wave nodes began to drift, not randomly, but in a slow spiral pattern that matched the orientation adjustments of Atlas's own axis. It was as though the sun wasn't merely reflecting Atlas's resonance, it was responding. The star had become part of the feedback loop. The harmonic mirror was evolving, shifting in real time, tracking the object with a precision normally reserved for engineered systems, not natural celestial bodies. Solar magnetic field lines around the affected zone also began to exhibit subtle reconfiguration. Field strength maps recorded minor but consistent realignment of magnetic loops, bending toward the region of harmonic imprint. Sunspots that should have been drifting independently slowed their movement when approaching the boundary of the resonance pattern. Even the small-scale magnetic bright points, ephemeral, short-lived structures, began to cluster unnaturally near the harmonic zone. Something about the imprint was affecting solar magnetism directly, subtly, but measurably, and if magnetism was being influenced, so too were the deep convection layers beneath it. That suspicion became undeniable when the Solar and Heliospheric Observatory, SOHO, detected a shift in subsurface wave travel times. These waves, which move through the sun's interior, normally follow predictable trajectories shaped by the internal structure of the star. But near the harmonic imprint zone, wave paths shortened by measurable fractions of a second. That may sound trivial, but in helioseismology, such deviations are enormous, the equivalent of finding a steel beam embedded inside what should be flowing lava. The sun's interior was being subtly redirected, as though Atlas's influence were reaching down into layers that no external object should be able to touch. At this point, the scientific debate fractured into two schools. One argued that Atlas was emitting a structured field, gravitational, electromagnetic, or something unknown, capable of influencing plasma behavior across vast distances. The other believed the Sun itself was entering a resonant state, amplifying Atlas's signals through internal feedback loops. In other words, the object didn't need to generate immense power, it only needed to trigger the right frequency. The Sun did the rest. But the most alarming development came from the heliospheric current sheet, the vast spiraling magnetic surface that forms the equator of the solar magnetic field. Data from Stereo A revealed that a small segment of the current sheet had begun oscillating out of phase with the rest of the structure. The oscillation matched Atlas's phase-lock frequency. A portion of the Sun's magnetic skeleton had broken rank, aligning itself with an interstellar object. In heliophysics, this was unthinkable. The current sheet shapes the solar wind. It influences planetary magnetospheres. It defines the electrical environment of the entire solar system. If Atlas could imprint a resonance onto even a sliver of that structure, then its influence was not local. It was systemic. That realization prompted emergency internal discussions across multiple space agencies. If the Sun was entering a synchronized state with Atlas, even at a microscopic level, then the harmonics could cascade. A small alteration in the current sheet, amplified by solar wind, could affect Earth's magnetosphere, radio propagation, atmospheric chemistry, perhaps even climate patterns. So far, no such downstream effects had been observed, but the potential was no longer theoretical. Atlas was interacting with the star in ways that no natural object should be capable of. The final confirmation came not from a solar instrument, but from a gravitational wave detector. LIGO, normally blind to astrophysical phenomena outside the massive and violent realm of black holes and neutron stars, recorded an unusual microresonance. Not a gravitational wave, but a subtle oscillatory drift in its baseline, matching, once again, Atlas's spin frequency. At first, the reading was dismissed as instrumental noise, but then the same pattern appeared in Virgo, and later, faintly, in Cagra. 3 detectors, thousands of kilometers apart, all picking up the same impossible signal. The Sun's interior was oscillating in a detectable pattern tied to Atlas. It was the ultimate confirmation that the synchronization wasn't coincidence. It wasn't passive. It wasn't harmless. Something about Atlas was reaching across space, touching the Sun and coaxing it into resonance, as if the object were testing the star, mapping it, tuning it, or preparing it for something humanity could not yet name. While teams across NASA, ESA, JAXA, and the Indian Heliospheric Consortium worked through the night to understand the harmonic imprint forming on the Sun, a second phenomenon began quietly, almost innocently, in the data stream from the Parker Solar Probe. At first, it looked like nothing more than a fluctuation in the probe's fields instrument, a mild modulation in magnetic wave intensity, but within hours it became clear that what Parker had recorded wasn't noise. It was a phase-lock signature. A solar phase lock, something previously believed to be physically impossible. The Sun's near-surface magnetic oscillations were synchronizing with an external repeating frequency that matched Atlas's precise rotational period down to the 4th decimal place. Parker had effectively heard the Sun singing in Atlas's pitch. The team at Johns Hopkins APL initially refused to believe the numbers. Phase locking is a phenomenon common in electronics, where oscillators fall into sync with a strong external signal. But in astrophysical plasma, in the chaotic convection zone of a star, that would require an external emitter of staggering precision, not brute power, but perfect coherence, something capable of imprinting its rhythm on a fluid sphere 1,000,000 kilometers wide, and yet the patterns repeated perfectly. Atlas spun, and the Sun answered. The degree of synchronization was subtle, less than a fraction of a percent, but unmistakable. The Sun's surface waves, particularly the low-frequency G modes that are notoriously difficult to detect, began to tighten their oscillation intervals, subtly but measurably, drifting toward Atlas's resonant frequency. A star was following the lead of a 200-meter-wide interstellar body. Scientists compared it to watching a mountain sway to the rhythm of a distant violin, something so small leading something so vast. But the most disturbing part came from an entirely different dataset, the solar neutrino flux. Neutrino detectors in Japan and Italy observed a minuscule phase fluctuation in arrival times. This had no known precedent. Neutrinos come straight from the Sun's core. Their flux should not be sensitive to surface events, let alone external synchronization. Yet a microscopic synchronization appeared in the neutrino stream, suggesting that the Sun's interior had begun responding in ways no astrophysical model could accommodate. If the Sun's core, the furnace of nuclear fusion, was entering a resonant microstate with Atlas, then the synchronization was not superficial. It was penetrating. The first major consequence appeared in the solar wind. Solar wind speed maps from ACE and the Solar Orbiter revealed a narrow corridor of wind flow beginning to align with Atlas's heliocentric longitude. An unknown process was creating a channel. Not a visible structure, but a preferred pathway of solar wind density variation. The corridor was thin, only a few degrees wide in heliographic longitude, but stable. And this corridor pointed directly toward the region of space where Atlas was traveling. Solar wind doesn't do this. It expands radially in all directions, chaotic and shaped only by the Sun's magnetic field. But here, an alignment was forming. A bridge of charged particles flowing along a path that should not exist. It was as if the Sun had begun whispering, sending a stream of particles toward Atlas like a beacon or a handshake. This prompted a new question among astrophysicists. Was Atlas merely influencing the Sun, or was the Sun responding willingly? A star cannot choose a T, of course. But resonance does not require intent. It requires compatibility. And something about Atlas's emission spectrum, its field geometry, its rotational harmonics, matched the Sun in ways no natural object ever had. As if to confirm that the connection was deepening, a new observational anomaly emerged from SOHO's LASCO C3 coronagraph. A faint, structured distortion appeared at the edge of the solar corona, a lensing effect not caused by gravity, but by refractive bending of plasma density. The distortion twisted in perfect synchrony with Atlas's rotation. Every time the object completed a turn, the corona shimmered in a repeating pattern. 3 faint ripples expanding outward like the wake of a ship. The pattern was stable, repeating, unmistakably tied to Atlas's spin. Once again, nature had no explanation. This phenomenon was dubbed the solar phase lock event. But the real shock came when the shimmer began to drift upward, not across the corona, but into the heliosphere itself. MAVEN, orbiting Mars, detected a faint echo of the same ripple pattern, not in light, but in ion distribution, a vibration moving through the solar system, subtle but coherent. A pulse, Atlas's pulse, reflected and amplified by the Sun. For perhaps the first time in human history, an interstellar object was using a star, our star, as a medium to transmit a structured signal across astronomical distances. When this possibility reached the upper levels of NASA and the European Space Agency, everything changed. The discussions shifted from physics to strategy, from curiosity to consequence, because if Atlas could turn the Sun into a resonant amplifier, then the synchronization might not be the end of something. It might be the beginning. As the solar phase lock event deepened, scientists expected instability, turbulence, or some kind of solar feedback disturbance. But what emerged instead was something far stranger and far more structured. ESA's Solar Orbiter, which maintained a vantage point inside Mercury's orbit, began picking up a faint geometric modulation in the ultraviolet band. At first the shapes were erratic and barely distinguishable, nothing more than interference patterns in the solar corona. But as Atlas continued aligning with the Sun's rotational harmonics, the structures sharpened, and then something happened that forced the Solar Orbiter operations team to stop treating them as noise and start treating them as information. The shapes began repeating. To understand the significance, you have to know what coronagraph interference normally looks like. Chaotic, irregular, distorted by plasma turbulence and magnetic loops that shift unpredictably. But these new patterns were different. They were angular, stable, and synchronized to Atlas's rotation period with millisecond precision. Even worse, or more fascinating, they drifted across the corona in a way that matched Atlas's heliocentric longitude to within 3 decimal places. Imagine looking at the Sun and seeing faint, recurring geometric shadows drifting across it like symbols carried on ultraviolet wind. The first recognized pattern resembled a three-lobed spiral, not curved like a natural plasma curl, but sharply contoured, with clean boundaries. It persisted for over 40 minutes, dissolving only when Atlas completed a full rotational cycle. 27 minutes later, another geometric form emerged, this time a hexagonal ripple with evenly spaced vertices and uniform phase spacing. Scientists compared it to the standing waves produced on a vibrating membrane, except the membrane in question was the Sun. The working group behind the Solar Orbiter's imaging system refused to label it a signal. They didn't dare. But the mathematics forced their hand. The harmonics underlying the hexagon matched not only Atlas's rotation, but also the oscillation frequencies it had imprinted earlier onto the solar G-modes. The correlation wasn't 10% or 50%. It was 99.97%. That level of synchronization simply did not exist in any known natural process. When NASA's Data Science Division generated three-dimensional reconstructions of the harmonics, the rendering revealed something no one expected. Depth. The shapes weren't surface distortions. They extended downward into the corona and formed layered formations, almost like holographic projections etched into plasma. One physicist described it as a solar tattoo, but even she admitted the analogy fell short. Tattoos don't move. These shapes pulsed, shifted, reconfigured, and re-emerged at precise intervals. And every time they formed, Atlas rotated in lockstep, as though the object were conducting a symphony the Sun had no choice but to perform. But that was only half the story. The other half came from Earth. While the Solar Orbiter captured geometric plasma harmonics, ground-based radio telescopes recorded something equally impossible: audio patterns. Not literal sound, of course, but modulated radio signatures that, when frequency shifted, produced waveforms indistinguishable from structured acoustic patterns. Nearly every one of them corresponded to the coronagraph shapes. A spiraling pattern in the corona produced a spiraling waveform signature. A hexagon produced a hexagonal modulation pattern. It was as though the Sun and Atlas had entered into a call and response dialogue carried on electromagnetic fields and ionized gas. The first scientist bold enough to suggest the obvious was a young radiophysicist at MIT who submitted a private memo late at night titled simply Harmonic Encoding Hypothesis. In it, she proposed that Atlas was not synchronizing with the Sun accidentally, but deliberately creating a medium, a holographic solar resonance, through which information could be embedded, stored, or transmitted. Her memo didn't try to explain how. It only pointed out that every time Atlas rotated, the Sun behaved like an enormous resonant canvas. Something was painting on the surface of a star. The shockwaves from that memo were immediate. NASA's internal Slack channels shut down temporarily due to the volume of cross-departmental traffic. ESA held an unplanned after-midnight conference call. JAXA convened its Solar Physics Division for the first time in years outside of a flare emergency. What frightened them was not the possibility of alien intelligence. What frightened them was how subtle the mechanism was. Nothing about the phenomenon was loud. There was no solar storm, no magnetic eruption, no violent interaction. Instead, everything was delicate, precise, almost careful. As if Atlas knew exactly how much to push without destabilizing the Sun. But the real breakthrough came when the shapes began interacting with each other across the solar surface. Two geometric forms merged, creating a compound pattern whose harmonic frequencies matched neither Atlas's rotation nor the Sun's oscillation modes. It was a new frequency, one never observed before in stellar environments. A frequency that, when plotted on a logarithmic analysis, mapped onto a progression not found in astronomy, but found in information theory. It resembled an encoding ladder, a structured, hierarchical series of frequencies designed to represent data layers, with each harmonic serving as a container for the next, like nesting symbols inside symbols, or compressing information through geometric resonance. No one wanted to say it aloud, but eventually someone did. Atlas might be writing. Not in ink, not in particles, but in the Sun itself. As this realization spread, more disturbing questions followed. Was Atlas using the Sun as a storage medium? as a transmitter, as a diagnostic tool, or, worst of all, as a beacon for something else. Because if Atlas could make the sun speak, then someone or something out there might be listening. And the solar hologram was only beginning to form. On the night of November 26th, as hundreds of observatories around the globe prepared for another routine 3I Atlas survey, no one expected that at that very hour one of the strangest and most inexplicable events associated with this object would occur. Before that night, scientists had become accustomed to Atlas constantly violating predictable behavior patterns. It changed brightness in ways that weren't consistent with photometric laws, exhibited accelerations that didn't fit into gravitational models, strangely synchronized its own angular momentum with the sun's rotation, and then showed signs of deliberate interaction with Earth's magnetic layers. Yet no one was prepared for what would happen when the spectrum reflected from the lunar surface suddenly ceased to be a colorless, empty line and transformed into something resembling a pulse, as if emanating not from the cold regolith, but from a structure capable of responding to external influences. When the first data began arriving at ESA's servers, it became clear that this wasn't just noise or another equipment error, but a subtle yet persistent wave that swept across the entire lunar surface, as if someone had glided across it with a soft yet incredibly precise energy instrument. This wave left no physical traces, no raised dust, no subtle changes in the temperature field, no mechanical vibrations that might indicate seismic activity. However, the spectrometers clearly recorded a response that resembled not reflected noise, but a coded modulation, as if the moon had not simply received the signal, but also returned it in a structured form. This discovery naturally caused confusion. The moon has neither a magnetosphere nor a dense atmosphere, nor any mechanism capable of generating such effects. But on this particular night, it behaved like a reflective nodal interface, a mirror capable of not only reflecting, but also responding. What happened after the initial response was even more shocking. Atlas changed the nature of its coma, and this change had nothing in common with the typical dust emissions observed in natural comets. The coma became dense and structured, as if the object were gathering material around itself, forming a shell resembling a thin energy layer directed toward the moon. Researchers noted the unusual geometry of this change because it couldn't be explained by solar wind or thermal load. It looked as if the object was preparing for the next stage of communication or a new experiment, with the moon acting as a reflector and Atlas itself as a transmitter of an unknown nature. It was at this moment that a new anomaly was noticed, which quickly became the central theme of all the classified reports. After Atlas received the first reflected pulse, it shifted its orientation slightly. This wasn't a chaotic rotation, not a reaction to external forces, but a subtle alignment that conveyed intention. The object's tail swung so that the direction of its radiation coincided almost perfectly with a line connecting the moon and a certain region of South America. And when experts realized that this direction intersected the zone of ancient geoglyphs, the Nazca lines, the situation ceased to be a mere scientific mystery. It became reminiscent of the choice of a point that, for thousands of years, human culture has associated with the sky, orientation to the stars, mysteries, and speculation about connections to cosmic phenomena. Scientists attempted to explain the phenomenon by a complex set of random factors: gravitational currents, statistical coincidences, or peculiarities in the object-Moon-Earth relationship. But when three independent stations, the American LRO, the Indian Chandrayaan, and the Chinese Chang'e, simultaneously confirmed that the moon was not simply reflecting a signal, but returning a sequence similar in structure to test responses from systems used in deep space communications, it became clear that this was not a random occurrence, but behavior that bore the hallmarks of searching for a communication channel. The second wave, collected several minutes later, contained 3 short pulses, as if Atlas were testing the channel capacity, response time, and stability range of the lunar surface as a reflective interface. It was in the context of these events that a previously unheard-of hypothesis was first put forward. Atlas might be using the moon not as a research object, not as a random reflector, and not as a data source, but as an instrument, as a reference surface for establishing communications, as a signal calibration point, as a node in a chain of interactions, with the moon serving as a screen and the Earth as a potential recipient. This theory seemed too bold, but it best explained the oddities in the coma's changes, the gradual increase in the directional flux, and the unexpected structure of the reflected pulse. When the third sequence of signals returned from the lunar surface, it no longer appeared as a soft, subtle wave. It was now a dense, confident structure, a pulse that resembled a genuine response, as if Atlas had checked the surface, waited for a confirmation, and then switched to the next mode. This series of pulses was later dubbed the lunar handshake, and it became one of the most discussed phenomena among specialists analyzing unusual astronomical phenomena. And at that moment, it became clear that Atlas no longer perceived our solar system as a space through which it simply passed. It was interacting. It was establishing a connection. It was using the moon as a reflector or a synchronization tool. And it was doing this so precisely that it seemed as if it had long known exactly what it was looking for.